away from simply factoring to solving. Now, today, as we are solving polynomials, can we put the laptops away, please? You technically already have all of the skills necessary to do this, or at least we've used all of the skills in this class to do this. We used them back in chapter 3, and then we've solidified them in chapter 4, or added some things to them. Now, today we're going to focus in on real solutions. We're not going to focus in on the imaginary ones. Can imaginary ones exist? Absolutely. Will we run across some of them? Yep. We're just going to focus on finding the real ones, though. We're going to start here. X cubed minus 64 is equal to 0. To solve a polynomial, we have a couple of options. Can you close the laptop down completely, please? But some of those options are a little bit limited. What do we know how to do so far with these higher order polynomials? What have we learned to do with something like x cubed minus 64 so far? It's a difference of cubes, and we can factor. We can use things like cube roots, but we're going to not do that on this for the sake of how we're going to get to other things. We've learned to factor these. Can you solve equations by factoring? Have we solved by factoring before? Yeah, back in chapter 3, we solved by factoring. The first thing, it has to be equal to what? 0. Done. Then we factor. This is a difference of perfect cubes. Again, difference of perfect cubes, factors like this. I have to figure out what's being cubed. What's being cubed to get x cubed? 1x. What's being cubed to get 64? 4. And if you're not sure, if you're just guessing, you got a calculator. 4 to the power of 3? Yep, it's 64. If you had guessed 8, 8 to the power of 3? Oh, way too big. I'm going to make it smaller. Still too big. Now too small. You could essentially just keep going through and cubing. But it is 4. This means A is x, or 1x. B is 4. A squared is x squared. And B squared is 16. So, I get A minus B is x minus 4. A squared is x squared plus AB plus x times 4 is 4x plus B squared plus 16. And it is still equal to 0. Can I factor a difference of cubes further? No, a difference of cubes will never factor further. Sum or difference of cubes. This looks like it's something that would. And you could try. You could do the shortcut. 2 things that multiply to 16 and add to 4. But do the 2 things exist? No. by the structure of how difference of cubes and sum of cubes factors, that will never factor through. Once it's in a factored form, we're using the zero product property. The only way things multiply together, and that's what's going on between the parentheses and get 0, is if you multiplied by what number? 0. We did this back in chapter 3. I take my two factors and I individually set them equal to 0 and I solve them. Now the one on the left is really easy to solve. X minus 4 equals 0. X is equal to 4, because I add 4 to both sides. There's one solution. X squared plus 4x plus 16 is slightly harder to solve, especially when I've already established factoring doesn't work. But that is quadratic, which means the things that I use to solve quadratic equations apply. I can't factor. We already established that. I've said it multiple times now. Can we use square roots to solve it? No, because it's got a regular x on it. You cannot solve by square roots if you've got x squareds and x's. It has to be only x squareds. Completing the square or quadratic formula are your options. Which would you prefer? Most people prefer quadratic formula. Quadratic formula needs to be in the form of ax squared plus bx plus c equals 0. Done. What's a? 1, the number in front of x squared. What's b? 4, the number in front of x. What's c? 16, the constant. It's registration today. Tomorrow is something else. But it is extended connections tomorrow, which means class does start at 9:30 tomorrow. Tomorrow, student survey. Okay, what is the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. This is where it's sad we had a late start on that day and we couldn't sing it to help you remember it. Okay, so negative b is 4 plus or minus the square root of 4 squared minus 4 times a times c all over 2 times a. I simplify the negative 4, the 2 times 1, and the stuff inside the square root. Do I include the square root in my calculator? No. Negative 4 plus minus square root of something all over 2 times 1. 2. Do I need the parentheses on the stuff in the square root? I need to make sure there's a times between these things. So those ones I could probably do without. If b is negative, does it need parentheses? Yes. If b is positive, does it need it? Technically, no. I just type it in as is. I get negative 48. Stuff inside the square root is known as the discriminant. What's true when the discriminant is negative? It's imaginary. What do my instructions say? Find the real solutions. Do I have to care about this anymore? Nope. So my only real solution for my difference of cubes problem on this one is 4. If I want to solve, I first need it equal to what? 0. Generally speaking, you want your first term, when it's in standard form, to have a positive x or coefficient. It's going to make life easier. So it's best not to move the 2x to the 4th and instead move the 16x squared and the 32. Remember, moving from one side of the equal sign to the other, do opposite operations. And then 2x to the 4th minus 16x squared plus 32 is equal to 0. When factoring, the first thing I should technically always do, I ignored it on the last one because I didn't need to. Greatest common factor, GCF. Biggest thing that divides out of all three of those is 2. Leaves me with x to the 4th minus 8x squared plus 16. Can I factor this further? Do you notice it's got 3 terms? Do you notice the exponent's bigger than 2? So it's not quadratic. But what do you notice about the 2 things that have the variable with the exponent? 2 and 4. Specifically, you're looking that this is double that. It's quadratic-like. 4 is double the 2, so it's quadratic-like. It's almost as if I have, now I'm going to ignore the 2. Heck, I'm going to ignore the equal 0. I'm just going to pull this stuff aside. It's almost as if I have, if I was to change it into the variable y, what would it look like? Y to what power? It's generally squared when I pull it aside because I changed this into x squared squared. Do I have to actually write x squared squared? No, I go directly to this. Minus 8 regular y. I'm replacing x squareds with y's. Plus 16 is equal to, not is equal to. I said I was going to ignore that. AC method? Shortcut? Shortcut. 2 things that multiply to 16 but add to negative 8. Negative 4 and negative 4. Y minus 4, y minus 4. Yes, you can write that as y minus 4 in parentheses squared. There's a reason I don't want to here. There's nothing wrong with doing that. But it was never y. It was x squared. Can I factor those further? The reason I didn't want to write it as y minus 4 quantity squared is because of the fact that I check for further factoring. And that's parentheses squared tends to mess with people with further factoring. I'll talk about it a little bit, but first I want to do it this way. Yes, I can factor further. It's got squared, so I got to at least try, which means I could do the AC method if I wanted. If I don't, or if I do want to do the AC method, what term is missing? X. It would be like having x squared plus 0 x's minus 4. And I'd look for two things that multiply to negative 4 and add to 0. Negative 2, positive 2, or it's a difference of squares. A difference of squares factors into double parentheses. The first thing that got squared was an x. The second thing that got squared was a 2 to get the negative 4, and one's a plus, one's a minus. Same thing I would have gotten had I done the shortcut. This other one's the exact same thing, so it's also an x plus 2 and an x minus 2. Well, that looks like fun. But it is fully factored. And when it's fully factored, I get a bunch of stuff getting multiplied together. 5 different things are being multiplied here. 2, x plus 2, x minus 2, x plus 2, x minus 2. Set equal to 0. Again, what's the only way you multiply a bunch of stuff together and get 0? One of them better be equal to 0. Is 2 equal to 0? No. Can x plus 2 be equal to 0? Yes, x would be negative 2. X minus 2 is equal to 0. Means x is equal to positive 2. Didn't I already do these two? Do you think I had to solve the same equations twice? No. If you notice they're the same, you don't have to do them twice. This is something known as a double root. In fact, it's actually a double root because there's 2 double roots here. There is a double root of negative 2, and there is a double root of x equals 2. Now we're going to go off on a little bit of a sidestep real quick with this. A root also goes by what name? A root, a solution, a 0, an x-intercept. When you have a double root, it's actually telling us something about our graph. It's telling us that not only does the graph hit negative 2 and positive 2 when it's graphed, but if I actually were to take a look at what the graph looked like, a vertex hits the graph rather than just a regular x-intercept. That's what happens when it's a double root. Now that's going to be something that leads us more into future chapter 4, but I wanted to at least mention it here. Okay, those were my 2 solutions. Let's try another. X cubed minus 32x is equal to 0. If I'm going to factor to solve, I should start with what? Greatest common factor. Actually, yes, you're right. Equal to 0. That part was just already done. And then greatest common factor. What's the GCF here? 2x. Don't just look at numbers. Make sure you're looking at variables too. When I divide 2 by 2, I get 1. That part's easy. When I divide x cubed by x, what am I left with? X squared. Far too many people on the quiz yesterday were not paying attention to their exponents. Minus 16 equals 0. Can I factor further? Yeah. That's a difference of perfect squares. That's a perfect square. That's a perfect square. Difference of squares goes into double parentheses. What's the first thing that got squared? X. What's the second thing that got squared? Not 16. What got squared to get 16? 4. 4 squared. And 1 is positive and 1 is negative. Could I have done the AC method? Yeah. Fully factored? Split. It is fully factored, so we split. Set equal to 0. One of the most common mistakes I see on problems like this happens in the split. People get x equals 4. People get x equals negative 4. Sometimes people make mistakes on that little solving because they get inside their head. So please, make sure you're doing opposite operations. And then they say that is my answer. What did I miss? The 2x. That gets set equal to 0 as well. Now sometimes another mistake happens here when people set 2x equal to 0. They get so used to adding and subtracting they forget that to solve this you don't add or subtract, you divide. Divide by 2. X is 0. This has 3 real solutions. 0, negative 4, 4. Next two are going to have something a little different happen with them. And they're our last two. Two x to the 5th plus 24x is equal to 14x cubed. Where do I need to start? Subtract that 14x cubed. To solve, I need equal to 0. To factor, I do greatest common factor first. 2? 2x. Can I factor it further? What kind of factoring? It's quadratic-like. It's kind of like having a y squared minus a 7y plus 12. Because 3 terms, and this exponent's double that one. Shortcut, two things that multiply to 12 and add to negative 7. Negative 4 and negative 3. Y minus 4, y minus 3. It's a nice thing about the shortcut is they don't have to do the rewrite step. Change it back. I replaced what with y? X squared. Is it always x squared? Technically, no. Is it most of the time x squared? But what if that was a 3 and that was a 6? Still quadratic-like. It would have been x cubed. If that was a 4 and that was an 8, it's still quadratic-like. It just would have been x to the 4th. X squared minus 4, x squared minus 3. Can I factor them further? X squared minus 4 is a difference of squares. Difference of squares pops up a lot. What was the first thing being squared? Just an x got squared. The second thing that got squared to give me 4 was 2. 2 squared is what gives us 4. One's a plus, one's a minus. What about x squared minus 3? Is that a difference of squares? No. 3 is not a perfect square. So that one doesn't factor further. I split. This one's easy, divide by 2, it's 0. This one's easy, subtract 2, it's negative 2. This one's easy, add 2, it's 2. How do we solve x squared minus 3 equals 0? Do you notice it's got x squared but not a regular x? Which means I can use square roots to solve. Get the x squared alone. X squared is equal to 3. To get rid of a squared, you take square root. When you introduce the square root, what are you introducing with it? Plus or minus. X is equal to a positive or negative. Can I simplify the square root of 3? No, it doesn't divide by any perfect squares. But that's an ugly number. Does that make it imaginary? No, what makes it imaginary? It was a negative inside the square root. It's not. For the record, how many solutions are on this problem? 0, negative 2, positive square root of 3, negative square root of 3. This is 2 solutions. You could still use square roots to solve. In all technicality, could I have used square roots to solve x squared minus 4? Did I have to factor it further to solve? No, I actually didn't have to on that one. Nah, we don't need the last example. I'm going to stop right there. Okay, today your practice problem's on page 188. Please write day 1 on it, because tomorrow we're also on page 188. It's problems 1 through 8 and then 11 through 18.